Yep, here we go. This now here I'm going to give you different examples asked in your past papers in terms of questions. For example, in your static equilibrium moment, you can resolve the forces, or you have to resolve the forces if the forces are not acting perpendicular to the line of force. For example, at this rod, there are several forces. One force is this one, that is 100 Newton, and then this is a force which is again 100 Newton, and that force is basically acting on it at certain angles. Did you see? That is acting at 30 degree with the horizontal, right? 30 degree with the horizontal. So I have to find out the perpendicular force. So when I'm going to find the perpendicular force, I have to resolve this from both ends. Here, this black component, did you see this one? This black component is basically equals to what? That is its sine component, and that red one is its cos component. So I have resolved that. So one of them is 100 sine 30, and the second one is 100 cos 30. In the same way, I have to resolve this one, as this blue is resolved into two. One is its this one, that is horizontal component 100 cos 30, and the second one, which is actually its 100 sine 30, that black component, that one, that is here. So which one are the perpendiculars? Black components. So I can say that the moment is equals to any one of the forces. So what are those moments? The moment would be, because this is the pivot, so moment produced on this rod is uh, anti-clockwise, isn't it? So that is why it is producing a couple. So what is the condition of a couple? Condition of a couple is product of any one of the forces and perpendicular distance between them. So you will say that it is F sine theta, any one of the perpendicular force, into the distance between force A and force B. That is, it is your force A and it is your force B. So what is the distance between them? Let's say 1, 2, 3, 4, 5, 6 centimeters. So that will give you this number, which I have calculated. It is 100 sine 30 into 6. It is 300 Newton meter. Now, this is a case which is asked to you in exam. Mostly, the students are stuck with that. This is the case number 2. In that case, there is a trap door, right? Did you see? This is what? This is a trap door, and this trap door is basically placed horizontally, and it is pivoted from this edge, from point A, and it is supported by a rope which is exerting a force at this angle 30 degree from its axis, and definitely this is a rope, so the rope will have tension force here, isn't it? Do you get it?
Yes.
So my immediate question is, if the rod has the weight of 500 Newton, how much weight does it have? It has 500 Newton weight. It is acting at this point, what I have mentioned. If I have not mentioned, no problem at all. This will be at the center of this rod, because this is the center of gravity. Okay. This is the uniform rod. So for uniform rods, the center of gravity or weight acts at its center. So about the pivot, what is the moment of the weight? Weight is 500, so it would cause a clockwise moment, isn't it?
Yes.
So when it provides a clockwise moment, so I can say that weight provides a clockwise moment. Okay, so it must be countered. So that is countered with the help of this rope. So rope has, because rope is not acting the tension is not acting perpendicularly, that is not acting at 90 degrees. So what I have to do, I have to resolve the force, I have to resolve this tension. So when I have resolved the tension into two components, these are two blue components. One component is vertical, it is called vertical component of the tension, and the second component is the horizontal, right? And this is called Tx. Yes, I have mentioned that it is Tx and it is Ty, or you can say T vertical. Okay, is it clear to you?
Yes.
Okay, so very important point here. As T vertical is perpendicular to the distance of 5 meter, this is the distance, which is actually your 5 meter distance, and that distance is perpendicular distance from this pivot point. Got it? And because weight is acting at a midpoint, so this distance 2.5 meter is the perpendicular distance for moment of weight. So weight is producing clockwise moment, and TV, vertical component of the tension, it is producing anti-clockwise moment. So they would counter each other. But what about the other component of the tension? This one. This component of the tension is passing through pivot. You have 5 more minutes. You have 5 more minutes. Okay, this component is passing through pivot. That is why it would have no moment, right? It will have no moment because it is passing through pivot, because it passes through pivot. So now when I will apply that, yes, I have mentioned this thing over here. Alhamdulillah, everything is what I have spoken, it is mentioned here. It is passing through a pivot, so it will have no moment at all. So when you are going to apply the moment of force, principle of moment, F1 D1 equals to F2 D2. So what is F1? F1 is your weight force. So 500 times 2.5, and on the other side, F2 is your T vertical, right? This is what? This is your vertical component of the tension. So you can say this is your T vertical, right? This is your vertical component of the tension. So that is your T sine 30. This is your T sine 30 into 5. So I got tension on the rope, that is, just I have rearranged 500 into 2.5 divided by sine 30 into 5. I mean 5 sine 30. So you get this value, which is 500 Newton. Right? Is it clear to you? Now the problem is you have to perform these three calculations. I mean, you did it. The T word tension is 500, vertical component of the tension is 250 Newton, and horizontal component of the tension is 430 Newton. How much? Sorry, 433 Newton. So you can simply write it 430 Newton. Is it clear to you?
Yes.
Yes. Yeah. Now there is a problem. As the rod is in equilibrium, so sum of upward forces must be equal to sum of downward forces. So that is why if I give you this condition again, this is a question in exam, that as the rod is in equilibrium, then according to the rule of forces, it is not. Did you check? Here, did you check that the force which was acting in the upward direction, that was vertical component of the tension, that was 250 Newton? Got it? Is it?
Yes.
And the force of weight, which was actually 500 Newton, it was acting downward. So 250 is not equal to 500. So it means law of Newton's law of equilibrium is failed. But how is it possible that there is a law and it is failing? It's not possible. That is why there is a fictitious force, a hidden force, and that hidden force is acting at the hinges, Remember this thing. Okay, just see.
Okay.
As I told you, that there is a force of tension which was 433 Newton acting on this rod, I mean at this pivot by the rope. This is actually Tx, right? Are you aware of Tx? What was Tx? Tx is the force of rope on the rod at pivot of rod. Pivot of rod, right? Are you clear about that? So definitely there would be a force which would be acted upon by the pivot on the rod. So this R is the force of pivot at rod, or you can say if it is fixed with the wall, as I have mentioned in my diagram. Yes, this is the wall. So definitely it would have the normal reaction force with wall. So you can simply say that is the force at the rod by wall. Yeah, you can simply say that this Tx is the force of rod at wall. So these are the points you must know about your diagram or about your question. So when you are going to handle these type of questions, these questions are actually mean sometimes they get horrible if you do not have a good concept. Now there is a problem in that one. The problem is this green one is the force, normal reaction force. So 433 Newton is acting towards right, isn't it? And how much force should be there? Force should be there, which would be used to balance 500 Newton, because that is 250, that is 500. So definitely this should be equal to, because sum of upward forces is equals to sum of downward forces, isn't it? Do you get it? So upward forces are 250 plus something. We do not know about that. There is a vertical force, but that is 500. So can I say that this vertical force will be 250 then? It means that on this rod, here at the hinges, here there are two forces, these two green forces, green lines, and these two forces are actually acting in such a way that one of them is acting to the towards to the upward, one of them is acting to the right. As a resultant, you are getting this force, black one, which is actually neither upward neither towards right, but resultant of this by Pythagoras theorem, 250 square plus 450, 433 square. So if you have calculator, please calculate it for me.
So can you scroll up? 50. Approximately 500.
Hmm. So approximately 500 Newton is applied here. Did you get it? So this all is really, really important, that we are asked calculate the net force acting on the rod, net force acting on the rod by the wall or acting on the rod by the pivot, and direction of net force is always towards the string. Again, an important point, right? The direction of the net force is always towards the string. Is this clear to you?
Yes.
Okay, good. So we will talk about uh, some other cases as well. I believe that you will not have any issue, because that was one of the case. It was horrible, and then this one, the ladder case. So I'm just talking about the ladder case here. This is a complicated diagram. Just let me check. Okay. Your moment will be over after this, right?